An iron rod is immersed in a solution containing nickel sulfate and zinc sulfate when the concentration of each salt is 1 m. Predict giving reasons which of the following reactions is likely to proceed, whether the first one or the second. And now remember the rule. The rule is that E cathode minus E anode should be positive. Okay, E cathode minus E anode should be positive. Now, using this rule, first you need to identify where oxidation or reduction will be taking place, and at cathode, reduction takes place. At anode, oxidation takes place. Okay. Based on that, can you tell me whether the first one, iron reduces Zn2 plus or iron reduces Ni2 plus, because in both cases, iron rod is being. So which one will be feasible, which one will not be feasible? So the first one says iron reduces zinc. Okay, means zinc sulfate. So if zinc sulfate is reduced, means that reaction is taking place at cathode. So I'm writing just this here, E cathode minus E N. Then now in first case, iron reduces, means iron itself gets oxidized because iron is reducing. Zinc zinc sulfate means Zn2 plus, we are writing in this expression, will get reduced. Oxidation, reduction. Okay. Now, here reduction potentials are given. So oxidation will happen at anode and reduction will happen at cathode. Means E cathode minus E anode in this case will be E cathode will be E Zn2 plus 2Zn, because here reduction is taking place at cathode, minus anode is E Fe2 plus F. So we need to calculate value of E cathode minus E anode, which will be E Zn2 plus is minus 0.76 volt minus E anode, that is iron, is minus 0.44 volt. Okay, so it will not be possible because it will be minus 0.76 plus 0.44, which will actually be negative. Minus 0.32 volt, it is not greater than 0. That's why the reaction will not be possible. So iron won't reduce zinc. Is that clear or not? How we will. A few points you have to remember: where the reduction is taking place, where the oxidation is taking place. So in question, it is already given iron reduces zinc sulfate. It means iron is oxidized, zinc sulfate is reduced. We already know. It means iron oxidized, that reaction will happen at anode. Zinc sulfate reduced, that reaction will happen at cathode. Then we will calculate E cathode minus E anode. If that value is positive, reaction will happen. If not, Yes, Shashwat, I'll explain that part. So I hope you have written what I have written here on the screen because I'm going to erase it. If not, quickly note it down. Then you will be able to understand easily. And remember, the same concept we will be using in 12th standard in electrochemistry. So there is entire chapter dedicated to electrochemistry. So same concepts will be used. So understand it again. Whether the reaction will happen or not, whether it is likely to proceed or not, that can be decided by the value of the electrode potential, which is at cathode, which is for the reaction happening at cathode, okay? Minus electrode potential for the reaction which is happening at N. Okay, this should be positive, means it should be greater than 0. Then reaction will happen, otherwise not. And we have already been given electrode potentials. We just need to find out. At the moment, we are talking about zinc and iron, so only first two. We just need to find out which one is related to cathode, which one is related to anode. So always remember, at cathode, reduction occurs. At anode, oxidation occurs. So these are the facts you should remember. Now it is given iron reduces, means that is Zn2 reduced, means Zn2 plus 2 electrons will give you Zn solid. This is reduction and its electrode potential is given minus 0.76. It is given. Then iron is oxidized because iron reduces Zn2 plus. Iron is oxidized. So it will be Fe Fe2 plus. Now remember, both electrons should have equal, both reactions, half reactions should have equal electrons because otherwise they will not get cancelled. Now iron is oxidized, it means it is off the anode, and for this one the electrode potential is given minus 0.4. Cathode and anode. Now we calculate E cathode minus E anode. E cathode minus E anode. In this case, that value comes out to be minus 0.32 volt, and the reaction will not happen because it is not greater than 0. Clear? Now come to the second part. Iron reduces nickel ion. Okay. Now, if iron reduces the nickel ion, we will apply the same concept. But now here we are comparing iron and nickel. Iron reduces means nickel is getting reduced at cathode. Reduction. And what is getting reduced? Nickel. Ni2 plus is getting reduced. Ni. Obviously, it will gain 2 electrons. And for this one, E is given 0. Minus 0.254. So E cathode is given. EC, okay? At anode, oxidation occurs. Because iron is reducing nickel ions, it means iron will get oxidized. And it is given minus 0.44 volt. Now calculate E cathode minus E anode. It will be minus 0.25 minus 0.44. That is minus 0.25 plus 0.4. Okay, means plus 0.19. As E cathode minus E anode is greater than 0, reaction will happen. Oops. Any confusion you can ask. Now moving to next question. Predict the maximum and minimum oxidation states for chlorine. What could be the maximum? So it is something you need to remember also. Obviously, you are not going to find out what could be the negative minimum or what could be the maximum. uh, sure, think again. Yes, Ashi, correct. Now remember, we talked about KC. Potassium is group one element always have plus one oxidation, and chlorine will have minus. But we also talked about ClO4 minus, for example, KClO. In KClO4, chlorine, if it is X, it will be plus 1 plus 4 times minus 2. X equals to 7. So whether it is written as potassium chlorate or it is written as only chlorate, it is same thing. You will get oxidation state as plus 7. So for chlorine, maximum oxidation state is plus 7 and minimum is minus 1. Yes, one Rashi, correct. Yeah, Preeta, correct. Now the next one, titanium. So as I said, you will have to remember these things. You are not going to guess in the examination. The answer has to be very good. Now titanium is actually E block element, okay? And it's a metal. So it cannot show oxidation state negative. It's electropositive. It cannot show negative oxidation state. So the least oxidation state will be in its elemental form, elemental standard form, and that's something I have already told you. In elemental state form, the oxidation state will always be 0. And the maximum oxidation state you can find from the number of valence electrons. Okay. So how many valence electrons are there in titanium? Yes, 4. Good. So because it has 4 valence electrons, at the most it can lose 4. It cannot have negative, so it cannot accept electrons, remember. So that's why it can lose only, and it can have +4 oxidation state maximum when it loses the 4. Okay. If you are not sure about, for example, how many valence electrons are there, you can write the electronic configuration also. Okay. Or you can write it is 22 atomic number, you can write 2, 8, 8, 4. Means 4 valence electrons. So as I said, for metals, minimum oxidation state is 0. For non-metals, yes, it can be group number -8. That is possible, but for metals, no negative oxidation state. Next question. Which of the following reactions are not feasible? Again, the same question. The first one, whether the reaction will proceed or not. So first you need to find out which one is the oxidation, which one is the reduction. So first find reduction. Why? Because we have to calculate E cathode minus E anode. And E cathode means reduction, E anode means oxidation. So first find, in all such questions, first find E cathode means reduction. So reduction is taking place here. Oxidation state +1 to 0. It means reduction and oxidation state is reduction. And the oxidation go to. So it means reduction is this electrode potential. Reduction, E cathode. Okay. E anode will be the oxidation. So this one is anode. E cathode minus E anode will give you the answer. So tell me whether it is feasible or not. Okay, okay. Fine. So it is feasible. Good. Yes. Prita Karan, correct. Good. One correct. Now the second one. I2 plus 2Br minus gives you 2I minus plus Br2. So I'm not going to tell you first. First, you need to tell me the answer, and then I'll explain. Find the reduction half, oxidation half, then do reduction minus oxidation potentials. Okay. E cathode minus E anode. Where do you have reduction? This one is reduction. This one is oxidation. So many wrong answers. Okay, now correct answer. Mehak, Preeta, Karan, Shashwat, Ashi. Correct. So means reduction is the cathode oxidation. And this one is cathode anode. Cathode minus anode. How do you say it is not feasible? Tell me the reason, because I'm sure 50% of you won't be able to tell me. Okay, good. However, 50% of the answers are wrong. Okay. So E cathode minus E anode. Okay, correct, correct. Why so many wrong answers? I'm not getting. 2.54 minus 1.09. So it is negative. So it will not be feasible. Those who have given it is feasible, just think about it. Okay, Shashwat. Okay. Okay, now correct Shashwat. Good. So negative, that's why not feasible. Now the next one. Again, you need to tell me first and then I'll explain. Find the reduction half, oxidation half, reduction minus oxidation will give you the answer. Okay, Preeta, Mehak, correct. Harsh, correct. Okay, now you are giving me correct answers. Everyone is giving me correct answer. Good. Good. So the reduction is plus one, oxidation is plus three, two, that is reduction, that is the code. Iron one is 0.77, and this is the reduction, sorry, oxidation minus 1 to 0, and here EA will be 0.54, EC minus EA will give you 0.77 minus 0.54, which is positive. So you need to calculate and then say positive, okay? Hence the reaction will be feasible. Yes, Shashwatahina Vanna. Yes, plus 0.23. Next question, next part. 2Ag plus 2H plus gives you H2 plus 2Ag. Quickly find the reduction and oxidation and tell me the answer. This one is very easy, so it should not be taking that much time. You even don't need to write anything here. Okay, Preeta, your answer is correct. Just tell me how. Something. What is E cathode? What is E anode? Just write the values and that's it. Okay, good, Preeta. Now, all these electrode potentials, okay, whatever we say, all these electrode potentials are with respect to hydrogen. Hydrogen's electrode potential is zero, means E H plus H. Okay, that will be all the electrode potentials are with in reference of the hydrogen. So here reduction is taking place. Why? Because plus 1 to 0 and this is at that here oxidation is 0.80. That means EC minus EA, that means E cathode minus E anode, 0 minus 0.8. Negative. Yes. So remember, the electrode potential value for hydrogen will not be given to you. You are expected to know that it will be 0. Next question. How does Cu2O act as both oxidant and reductant? Explain with proper reactions showing the change of oxidation number in each case. In one case, it is acting as oxidizing agent. In other case, it is acting as a reducing agent. And this is just you need to know the reactions. These are type of reaction questions where, as I said, you don't need to think in the examination room. You should already know. So note down the reactions in both cases. So for example, when we are talking about C2, copper is in plus one oxidation in this. It is actually Q plus oxide. Q plus oxide on copper one oxide. As I have already told you, these are the stop notations. If I write the oxidation state in brackets, it is known as stop. So write down the reaction. Now, in this plus one oxidation, when it reacts with oxygen, then it is oxidized to CuO, means the copper one oxide is converted to copper two oxide, means from cuprous oxide, it is converted to cupric oxide. Yes, Rashi, I'll show you the previous slide. So CO2O is oxidized, means itself it will be acting as reducing agents. So CO2O acts as reductant or reducing agent because CO2O is getting oxidized from plus one oxidation plus oxidation. Now another one where it acts as oxidant or oxidizing agent when CO2O reacts, or rather C2S reacts, it gets reduced to copper. And this is one of the methods of extraction of copper. Metallurgy, the whole chapter is devoted in 12th standard. The same reaction we will be talking about in 12th also. So here if you see oxidation state changes from +1 to 0, means reduction is taking place. If reduction is taking place, it means this itself is acting as oxidant. It is getting reduced to copper, but it means it is acting as oxidizing agent, oxidant. So remember both the reactions to answer these type of questions. Next question. At what concentration of zinc ion will its electrode potential become equal to its standard electrode potential? So basically, the question is asking whether you know what is standard electrode potential or not. That's simple. Obviously, it will be always be electrode potential, but for it to be standard electrode potential, there is just one condition. That condition you have to mention here. When the electrode potential becomes standard electrode potential. No, that is something related to the concentration. Okay, so when the concentration 1 m is 1 mole, 1 mole per liter, and that is the definition of standard electrode potential. That is when the concentrations of all the species are 1 m. So here we have only Zn2 plus. So its concentration will be 1 m, then it will be standard electrode potential. Yes, Ashi, correct. Uh, well, this is something, Ashi, we will be talking about in 12th. That is not always true. Okay. So that is something we will be talking about in Nernst equation. Yes, from 11th perspective, that is fine. Same question, but here asked for plus. Again, the same answer. It will be standard electrode potential, whether it is U2 plus, whether it is Ni2 plus, whether it is Zn2 plus. It will be standard electrode potential. One, one molar. Okay. Next question. The E naught of aluminium and copper are given. Is the cell feasible or not? Now, this is the same question what we have done, but it is asked differently. Okay. Basically, it is checking whether you know how the cell is represented or not. So if you know how the cell is represented, you can solve it because you already know E cathode minus E anode should be greater than. Okay. Now, this one is not feasible. And how we will find it is not feasible? Because first we need to find out where the oxidation is taking place, where the reduction is. So in the cell representation, it is oxidation reduction. Okay. Yes. So when we are writing it here, this is first is written as Cu2 plus. The second one is written as Al3 plus 2 here. So based on that, yes, oxidation and reduction. So if we talk about E naught of copper, it is 0.34. Okay. However, E naught of aluminum minus 1.664. It is giving to us that E naught aluminum. Again, remember these are the electrode potentials only, reduction potentials. So whenever these are given, these are not oxidation potentials. The E naught are always reduction potentials. So it is minus 1.64 and for copper, okay, plus 0.34. Now, how the cell is written, if you understand that one, that will give you the answer. Okay. So these values are actually reduction potentials. However, there is another way if you talk in terms of oxidation and reduction and not the reduction potentials, then their sum should be greater than zero. If you are talking about oxidation and reduction, not just the reduction potentials. So why I'm telling you that? Because in the question, you may not always be given the way as you are doing. However, this question we can solve E cathode minus E anode. There's no problem. Something more about it. Suppose it is not E cathode minus E anode. It is electrode potential if we are talking about at cathode. Okay? And we are talking about at anode. At cathode, it is because reduction, we will take E naught as it is, reduction potential. But at anode, because oxidation is taking place, we can take it that instead of reduction, I take it oxidation potential. Obviously, it will be negative of the given value. Whatever is the value for reduction for anode reaction, it will be opposite. And then obviously, instead of doing cathode minus anode, you can add, in that case, E cathode or E1, E1 plus E2 should be greater than 0. At anode, sometimes instead of reduction potential, I'm erasing this. Oxidation potential might be given. Okay, as oxidation potential is negative of reduction potential. So in such cases, reduction potential of reduction reaction and oxidation potential of oxidation reaction, because at anode oxidation is taking place. So suppose reduction potential of the reduction reaction and oxidation potential of the oxidation reaction, these are given, then instead of difference E cathode minus E anode, you will add them. Why you will add them? Because oxidation potential is already negative of reduction. That is something you need to remember. In quite a few questions, your teachers, instead of reduction potential, can give you oxidation potential. Okay. Now, in it is always recap. Okay. So it will be, in this case, all these are reduction potential. None is oxidation potential. If it is oxidation potential, that will be written specific. Okay. So this will be 0.34 minus 1.66. That is 0.34 plus 1.66, which will obviously be positive. Hence, reaction will not happen. Next question. A solution of silver nitrate was stirred when an iron rod with an iron rod. Will it cause any change in the concentration of silver and nitrate ions? Again, the same thing asked differently. It is asking whether the reaction will happen or not. If reaction will happen, there will be change in the concentrations, otherwise not. Tell me the answer. You have Fe plus Ag plus. Silver nitrate is AgNO3. If you write Ag plus. Tell me whether the reaction will happen or not, or whether there will be any change in concentration or no. Your answer will be whether there will be any change in concentration of silver and nitrate ions. Okay. Okay, tell me the value of E cathode and E anode. E cathode and E anode. And what should be the value of E cathode and E anode? E cathode minus E anode. Okay, good, good, good. शाश्वत, महक, करण, प्रीता, आशी, राशि, शाश्वत. Okay. Now, again, the question is whether there will be any change in concentration of silver and nitrate ions. Something extra is required here to think into that direction. Your answer is correct. Your answer is okay. In that sense, your answer is correct. That reaction is feasible. Okay. But something which is obviously the common sense. Okay. So if we are talking about silver, that yes, the concentration will change because Ag plus will get converted to Ag. Nitrate. Nitrate ion, it was AgNO3. It means it was 2Ag plus 2NO3 minus. And after that, it will produce FeNO3 whole twice, means Fe2 plus 2NO3 minus. So although you will find whether the concentration of silver will change or not, depending on whether the reaction is feasible or not, the concentration of nitrate here is not changing. It is just getting detached from silver and getting attached to iron. Is that clear? So the concentration of the ions may or may not change if one ion is getting detached from one and getting attached from the other one. So concentration of Fe2 plus ions will increase. Concentration of Ag plus ion will decrease, but of nitrate ion will remain. Is that clear? Any confusion? Ask. Obviously, you will apply the principle, you will apply the rule to find out whether there will be reaction or not, but you need to be cautious that there may be some ions whose concentration may not change even if the reaction is taking place. So the concentration of nitrate ion remains unchanged. Next question. The electrode potentials of four metallic elements PQRS are given. Arrange these in order of decreasing electropositive character. Now there is relationship between the electrode potential and electropositive character. So this is just to know that and you will get the answer. Where the electrode potential, if it is not written, it is always reduction. So if reduction is not written, it is always reduction. So there is no need to write reduction potential. If it is written, that's fine. But for electrode oxidation potential, oxidation keyword must be written. Lower the electrode potential, sorry, lower the tendency to lose electrons, and therefore lower is the electropositive character of. So remember the relationship first, and then we will get the answer. The relationship says higher the electrode potential, okay, lower the electropositivity. Now you have been asked to arrange in the order of decreasing electropositive character. Means you have to write least electropositive on the right hand side and most electropositive on the left hand side. This is what is asked. Decreasing electropositive character means least electrode potential here, highest electrode potential on the right hand side, because both are inversely proportional. If electrode potential increases, electropositivity decreases. So if electropositivity is least, electrode potential must be highest. So arrange these. If you arrange from least to highest, it will be minus 0.74, minus 0.31, plus 0.79, 1.08. Clear? It means 0.74 is related to Q, will be Q. Then minus 0.31 is S, 0.79 is of P, and 1.08 is of R. So it will be Q, S, P, R. Decreasing order of electropositive character. If it is clear, fine, else let me know if there is any confusion. You just need to remember the relationship electrode potential, that is, the reduction potentials are inversely proportional to electropositivity. Write that relationship and memorize. The answer was QSPR. Next question. Permanganate ion reacts with bromide ion is in basic medium to give manganese dioxide and bromate ion. Write the balanced chemical equation for the reaction. Tell me the reaction in the chat box. Permanganate means potassium permanganate, for example. That is skeletal one, Shashwat. Tell me the balanced one. Okay, I think I'll have to. Yes, number of ions will be included, Devansh. So, yes, balanced equation, probably you guys have balanced it through oxidation number method. That's good. So, Shashwat, that is a skeleton. Ashi, correct. Devansh, that is uh, electrons are not balanced. Okay, so, we don't have much time, so that we do it. So, we will write the skeletal equation. So, permanganate is MnO4 minus, and we get bromide ion. So, bromide ion. And in basic medium, obviously, we will use OH minus later on to give manganese dioxide and bromide ion. Bromide. Okay. Now, here it is +7, here it is 4, it is -3, here it is -1 to +5, so here it is +6. So we need to equate it, means we need to multiply the reduction by 2, then it will be -6, it will be +6, they will be equal. It means we need to multiply the reduction half by 2. So it will be 2MnO4 minus plus Br minus gives you 2MnO2 plus BrO3. After that, once we have done the balancing of oxidation states, now we will see that we need to balance the charges. And because it is basic medium, we will balance the charge. It is -2, -1. Here we have only -1. It means we need to add H minus. So -1, -2. On both sides, we have -3. We balance the charges. Now, once we have balanced the charges, we need to balance the hydrogen. So we have 2H here. It means we have to add one H2 on the left hand side to balance these 2H. We will add H2 on the left hand side. Okay. So once we add H2, we will see that oxygen should get balanced automatically. So we have 2 4s are 8 oxygen plus 1 oxygen. Here we have 2 2s are 4 on the right hand side plus 3 plus 2. So we have on left hand side 9, on right hand side 4 plus 3 7 9. So oxygen got balanced by itself. So this is the balanced.